All right, so the next lecture I want to cover is over something called dimensional analysis. And this may be something you remember from chemistry. It is when you work with units that that don't always change easily. So, for instance, maybe you want to know how many meters are in a mile, and you have to go from metric to English. So we use a technique called dimensional analysis, which allows us to show our work and come up with a solution. So what we're doing here with dimensional analysis is we are multiplying by 1 to change units. Really, that's all we're doing. So we multiply by 1 a bunch of times, and this allows us to change units by multiplying by 1 and using conversion factors. So when each time we multiply by 1, we use something called a conversion factor. So we multiply by conversion factors. Okay, so when we do this, what I guess a good thing to state then is, what is a conversion factor? So let's start with that first. Right? How are we using conversion factors, and what the heck is a conversion factor? A conversion factor is an equality written as a fraction and the fraction equals 1. So we'll get a little practice here writing these conversion factors. So for instance, let's take 1 dozen cookies. 1 dozen cookies is equal to 12 cookies. Right? They're equal. So we can write that as a conversion factor. For instance, I could write 1 dozen over 12 cookies. Or I could write 12 cookies over 1 dozen. What's important here is that this, if we do the division, if you took a dozen and divided by 12 cookies, you would get the number 1 because of the same thing, right? If you take two numbers or two things, right, like 6 divided by 6, we know that that's equal to 1, or 3 divided by 3, we get 1. So any two quantities that are in a fraction, and we divide them, this would go into this 1 time. And so 12 cookies goes into a dozen cookies 1 time. And because of the same thing, this is the same amount of cookies. This is 12 cookies, this is 12 cookies. But what's special about it, you can see, is that the numbers are different because the units are different. But it's still equal to 1, right? And this is still equal to 1, even if I write it different, because there's still the same number of cookies in either case. And we like to write these like this as fractions, and this allows us to change units by multiplying by 1, is the idea behind a conversion factor. All right, so let's go ahead and look at some problems. Or, yeah, some example problems. So the first thing I would say is let's just pick let's say we have something easy. We have three dozen cookies. So I'll go ahead and we want to know how many cookies that is. Equals blank cookies. All right, 3 dozen is equal to how many cookies? And you'd be like, well, a dozen is 12. And assuming a dozen is 12, if it's like, I don't know if it's a baker's dozen or whatever, then it's 13 or something. I can't remember. But let's just assume a dozen is 12, just normally. A dozen is 12, and we want to know how many cookies that is. So 3 times 12 is 36. And you might say, oh, 36, and be done. That's not the point of what we're doing here. And so what you have to realize is when you're doing conversion factors, I always want you to show your work. Because what we're after here is the method. We're trying to learn how to use conversion factors more so than we are just trying to get the right answer. So the method is what I want to see here. So when you get a problem like this, what you do is there's rules, right? Just like there was before. So if I was going to come up with some rules, I would say the first rule is start by writing what you have. So these are conversion factor rules. Okay, so rules for conversion factors. Number 1, start by writing what you have. So if I go back to this problem, what do I have? Well, I want cookies, but I know I have 3 dozen. So I'm going to start by writing 3 dozen. Then I want to find some equalities that will allow me to write conversion factors. So rule 2 would be to find equalities. I could say an equality. I'm going to write find equalities that that involve. I'm going to say that involve the units given. And then the reason why I said equality is plural there is because sometimes we can find just one conversion factor or one equality that'll allow us to solve the problem. But in other cases, it's going to take multiple equalities. So we're going to find equalities that involve the units given. And then we're going to write or maybe I should say build a bridge using the equalities and then write conversion factors. All right. Okay, so let's go ahead and look at this and see how this relates. So the first rule said start by writing what we have. Then rule 2 was find equalities that involve the units given. All right, well, we know for this problem that an equality that involves the units given is the fact that 1 dozen is equal to 12 cookies. And rule 3 says build a bridge using the equalities. So our bridge would be just going from dozen to cookies. That's pretty simple, right? We just need one equality and that's it. And then rule 4 says write conversion factors. Now let's be a little more specific here. Write conversion factors, or maybe I should say instead of write, why don't we say multiply by conversion factors with the trash units canceling. Now usually that's going to mean put the trash on bottom. Usually. It's not always true, but usually. All right. So far we've got quite a few rules already, and maybe I can get a marker here and try and separate these rules a little bit. All right, so it's something like this, right? And I can get rid of this, make it a little cleaner looking. All right, so something like this, right? And so now we're gonna multiply by conversion factors with the trash units canceling. So why this is a hard step here, right? Is that we know that 1 dozen equals 12 cookies can be written this way. And it can be written this way. And which is the correct way, right? Because we want to multiply it by this 3 dozen, right? We said multiply by conversion factors. Well, there's this conversion factor, there's this conversion factor. Which one do I multiply by? Okay, well, I'm going to do it in a way that cancels the garbage unit. Well, I don't want dozen anymore, and I want cookies, so dozen is the garbage unit. So I'm going to write it in a way that I get rid of dozen. Dozen is going to be on bottom so that it cancels. The reason why is what we're doing here is we're treating our units just like numbers. So notice I'm going to just write the units in. I'm going to write dozen in. I'm going to write cookies up here. The numbers just follow the units, right? And that's kind of one of the key ideas of conversion factors is we're changing the units and the numbers just go for the ride, and that will allow us to solve the problem. Now you might say, well, this is a fraction here. What about over here? Well, this is also a fraction. You can always think of it out as being over 1. All right, so we're going to multiply. We can go ahead and put some numbers in. We look down here and we see that, well, the number 1 goes with dozen because 1 dozen is equal to, and the number 12 goes with cookies because it's equal to 12 cookies. But it's important, right, that we use this one and not this one, right? This one was wrong here to use, because then you would end up with dozen times dozen, which would give you dozen squared. Instead, I want to be able to look up here and say dozen divided by dozen, right? Anything divided by itself cancels away and becomes just 1, right? This is just 1. And so now I'm done, right? I'm done with the problem in so far that it's now time to go to the next step. Why do I know that? Because I have the units I want, which are cookies. And so this means the next step is to multiply the top across. So I guess I should say, before you do this, make sure let me write this first. You are done with conversion factors once you have the unit. Once you have the unit, the units you want. All right, so that's how you know you're done, right? So we know we're done because we're in cookies. All right, then the next step is to multiply the top across. Multiply the bottom across. and then finally divide. Okay. And so something I should mention with step 5 is you're done with conversion factors once you have the units you want. This involves canceling, right? That involves canceling out the units you don't want. All right, and I think that should be good. I think that's it. Let's go back and apply the rules to our problem. Okay, so here we have we left off dozen became 1, dozen became 1, multiply. Now we can multiply the top across, right? This is being multiplied because we have this multiplied by that. Multiply top across, so 3 times 1 times 12 times cookies. And just so I can show my work here, I'm going to rewrite everything over here so you can see what I see and make sure we're on the same page. On the bottom, 1 times 1 times 1. Notice I'm not writing the ones. I'll write 1 down here just so you can see, but I didn't bother writing the other ones. So 3 times 12 is obviously 36, but it's also not just 36, but the answer is 36 cookies. So we want to make sure, I'll write that right up there. We want to make sure that we write our units, right? We did all this work to get our final answer, and we want to make sure we write the units with it, because that was the whole point of the problem, was you were changing the units. Okay, so I think you kind of get it, and maybe you are ready to see a more complicated problem, right? Okay, so let's take a look at another example. One I'll do right off the bat. We'll say just to do a counter example to the last one. What if we were given the opposite? What if we were given 100 cookies, right? Let's say you went to McDonald's and you ordered 100 cookies. They'd probably tell you to get lost and go home and make your own cookies, right? But let's say they had a surplus of cookies and they could fulfill the order, and you ordered 100 cookies. So if you were able to do this and you wanted to know how many dozen of cookies did you order, right? So this is a little trickier, right? Because 12 doesn't go into 100 easily, right? I think 12 times 8 is 96, so this is probably a little over 8. But what if the problem was you had to show your work and do the conversions? So now this is the problem, right, is equal to how many dozen. So the first thing our rule was start by writing what you have. So I'm going to start by writing 100 cookies. Okay, now I'm going to find an equality to give us the units we need. Well, we already know the equality, right? It was written a couple times, but I guess it's 12 cookies equals a dozen. And I don't know, where am I? Oh, here it is. So do I use this one this time or this one, right? Because 12 cookies equals a dozen. So this time I want to get to dozen, so my trash unit is cookies. So I need to use the conversion that will allow me to get rid of cookies, which is this one. So what I'm saying is when you write your conversion factor, right, I don't care about the numbers, I care about the units. The units I want to cancel goes on bottom. And because I want to cancel this, right? And dozen is going to go up here. Now, it doesn't always work out that it's that nice because maybe you don't know the equality. Maybe it takes multiple equalities or multiple conversion factors. But in this case, it's super nice, right? Because cookies will divide cookies, and I'm left with dozen, which is what I want. And so I can go ahead and put the numbers in. 12 cookies is equal to 1 dozen. And so I'm done now, right? I'm done because I have the units I want on top, right? So we did rules 4 and 5 here. You're done if you have the units you want. And now we got to multiply the top across, multiply the bottom, and divide. So I'm going to go ahead and rewrite to keep this so you can see what's going on. 100 times, this just became 1. So I don't write the 1 times dozen. And here we're thinking of units then just like numbers. That's what's kind of new, right? Dividing away units. On bottom, well, this is just a 1. this is a 12, this is a 1, so we just have 12. All right, so we're going to go get our calculator. 100 divided by 12 should be a little over 8. 8.3 repeating. All right, so our answer is going to be 8.3 dozen. All right, so you go to McDonald's and ask for 8.3 dozen cookies, and they will give you 100 cookies. All right, that's all there is to it. All right, let's see another example. I guess before I do more, let's gather up some equalities because I want to make sure you know some of the common conversion factors you might get asked in this class. So here's some equalities, and a lot of these I would give you on a test, but sometimes I'll make you write your own, and I'll try and explain that later. All right, so some common equalities. You might say, well, 1 foot is equal to 12 inches. All right, pretty straightforward, pretty simple. What about this one? 1 inch is equal to 2.54 centimeters. That's nice because it goes from English to metric, so I really like using that conversion factor a lot. Here's another one. 1 mile is equal to 5,280 feet. And 1 mile is also equal to 1.609 kilometers. All right, let's get some more. 2.2 pounds is equal to 1 kilogram. All right, that goes from weight to mass. That's interesting. These aren't even the same thing, really, because one is based on the gravitational field of the planet you're on, and one is just based on the amount of matter, which is mass. What other ones? Let me see if I have any more written down. I guess some common ones might be that, and you should probably just know these ones, but I'm going to write them anyways. 100 centimeters is equal to 1 meter. 1,000 meters is equal to 1 kilometer. And let's go 1,000 millimeters is equal to 1 meter. So with these ones, or I guess with all conversion factors, let me just point something out. I could have went back and redid this last problem with a different conversion factor. Let's say for some reason you were like, oh, well, I just have to use an equality. So I'm going to go back and do this and solve using the fact that 2 dozen is equal to how many? How many cookies? Well, it would be 24, right? Is equal to 24 cookies. And what I'm saying is, if your equality is the fact that 2 dozen is equal to 24 cookies, that's fine, right? That doesn't change anything because this is still equal to 1, right? When you divide these, it's equal to 1 because this is the same as this. So check it out, right? You go ahead, you go through it, you cancel, you're like, oh, I'm in dozen, I'm done. So then you multiply the top across, 100 times 2 times dozen. You might say, what? The numbers are definitely different. Not even close, right? But watch, right? You got a bigger number on bottom too. So this is just a 1, 24, and a 1. So you just got 24 on bottom. And now you can see where this is going, right? 200 dozen divided by 24. You go grab your calculator. You turn it on, 200 divided by 24, and you get 8.3 repeating, right? So it doesn't matter. So you can solve these with different conversion factors as long as you know the equality, and you're going to get the same answer, right? Okay. So if I if I go back to this, I just want to point that out because here you might say, well, can I use 200 centimeters equals 2 meters? Sure. Or 4.4 pounds is equal to 2 kilograms? Sure. You know, and you can just keep doing that and, you know, writing them differently. These are the ones, the common ones I would give you if this was a test. Because I don't expect you to memorize some of these. Some of these ones I might, because I think you could come up with these on your own. And I'll mention how you do that. Well, I guess I could just mention it right now, right? If a student asked me, well, how many centimeters are in a meter, and it was a test, and it wasn't given, what I would tell the student is, I'd say, okay, well, why don't you go back and figure it out? Go, you know, not being mean, right? I would give them this hint. I would say, the question is, how many centimeters are in a meter, right? So I would say, write down 1 meter, and then write down equals blank centimeters. And so what I did there is I turned it into a conversion factor problem, right? Which they can figure out on their own, right? They know they jot the decimal point down. They're in meters. They're at the base. So the base is right here, right? This is where meters is, right there. And then this is centi, and this is deci. I'm sorry. This is centi. This is milli. And then they have to go from meters to centi, so they're going to go from meters, right? This is milli, this is meters. So they're going to go from meters to centi. They're going to go 1, 2. So their decimal goes 1, 2. Right? So I have 100. And so that's how I would tell a student if this was a test. I'd be like, you can figure that one out yourself, and I'd give them that little hint and show, and then they could do it, and that'd be good. So you don't have to memorize all of these, but some of these ones are kind of arbitrary, like 1 inch equals 2.54 centimeters. You got to memorize that, or someone's got to tell you that one. Okay, good. Let's go ahead and put some of these to use. All right. All right, so the next example we'll do is, let's say you're in the weight room and you reach for a 45-pound plate. And you want to know how many kilograms that is. And because you notice in the weight room that sometimes the plates have pounds on them, and sometimes they have kilograms, and you kind of understand that they're similar, but they're not the same because this one's weight and this one's mass. But you want to go ahead and figure this out. You want to calculate this. So, all right, so what you do is you just follow your rules, right? Start by writing what you have, which is 45 pounds. You go ahead and write that. Next thing I'm going to do is find an equality that will allow me to make a bridge from pounds to kilograms. So I look right here and I see 2.2 pounds is equal to 1 kilogram. And you might be sitting there saying, well, then I just divide by 2.2. Remember, we're trying to learn the method here, not necessarily the answer. All right, and I know that's tough for some of you, but on a test, the points for this question will mainly come from the conversion factors, not necessarily the right answer, because I want to see if you can learn the method. All right, so that's what we're after here. All right, I know that's hard because sometimes you're in classes and it's always about just getting the right answer, and that's not this class. Okay, so 2.2 pounds per kilogram. Now the question is, where do I write pounds and where do I write kilograms, right? I know they're equal. Well, I put them so I can cancel my pounds, right? So I know I'm going to put it down here. This is over 1. I know I'm going to put this down here because this is a fraction, and I'll put kilograms up here, and because I want to cancel these two. And you might say, well, can I just do that? And yeah, you can, because this is almost like one giant fraction. That's how you can think of it, right? You're multiplying two fractions. It creates just one giant fraction party. All right, so the numbers now need to go in here. And what numbers go where? Well, go back and look. Looks like 2.2 always goes with pounds and 1 always goes with kilograms. All right, well, the 1 always goes with kilograms, so the 1's got to go there. And 2.2 always goes with pounds, so it's got to go there. And now I'm in the unit I want, which is kilograms. So now I'm done, right? All right, so now I can go ahead and multiply the top across. That's my next rule, 45 times 1 times 1 times kilograms. So I'm only going to write the things that are not 1. Multiply the bottom across, 1 times 2.2 times 1, so just 2.2. So this is how I'm showing my work for all of this. Then I will go ahead and get my calculator, take 45 divided by 2.2. And I call this the rewrite step right here. If this was a test, you would have to definitely do this. If there was a step you left out, it would be the rewrite step, and I'd be fine with that if you didn't have this rewrite step. That's okay. But I'm going to always do it because I think it helps students learn the method. All right, so 45 divided by 2.2. I don't know if you can see that. Looks like I'm getting some shadows there. 45 divided by 2.2, 20.45, and I'm just going to stop right there, 45. The 4 does not cause the 5 to change, so I'm going to leave it there, 20.45. Remember, as long as I go 2 or 3 past the decimal, we should be all right. And you might say, well, that's not very scientific just to say 2 or 3. You're right. There's sig figs, significant figure rules help with that, and we're just not worrying about that in this class. All right, so I'm going to go ahead and put a little square around that, indicating that I'm done. So next time you're in the weight room, say, oh, just hand me that 20.5 kilogram plate over there, and they might, they might understand, I guess, if they're in this class. But yeah, or check that plate and make sure it is 20.45 kilograms and see. So that should read that number should be on the 45 pound plate. Okay, let's go ahead and do another problem. Next one, how many centimeters are in 1 mile? So I'm gonna write, I'll just write this down right here, blank centimeters equal 1 mile. All right, so just like before, we're going to start by writing what we have. Well, we want to know centimeters. We have 1 mile, so I'm going to start by writing 1 mile. I am then going to look for equalities that deal with miles and centimeters. Notice this time it's a little harder, right? Because I don't have any miles to centimeters on here. I have miles to feet, miles to kilometers. So we have to build some kind of bridge. So there's multiple ways to do this, right? Definitely. So what I'm thinking here, if we want to go from miles to centimeters, maybe we can go from miles to feet, feet to inches, inches to centimeters. See how I did that? I used 3 conversion factors. One more time, miles to feet, there's 1 conversion factor. Feet to inches, there's 2. Inches to centimeters, there's 3. What about another way to do it? You see any other ways? What if we went from miles to kilometers, kilometers to meters, meters to centimeters? Aha, that'd be 3 conversion factors again. So you get the idea, right? And let's take a look at how this works. So let's see how this works. I was gonna add something in, but I'll hold off on it. Let's do the first way. I kind of like that. I think that's kind of neat. So miles to feet, feet to inches, inches to centimeters. All right. So if we come back here, we're thinking 3 conversion factors. So I'm saying I'm going to go from miles, because I'm going to get rid of miles. So I'm putting it on the bottom, to feet. Now I'm in feet, so I can show you what I'm thinking here. Cancel my miles. I'm in feet now. Notice I'm not writing the numbers. I don't care about the numbers. Then feet to inches. All right, check that out. Cancel that. All right, now we're in inches, but we don't want inches. We want centimeters. So we can then need 1 more to go from inches to centimeters. See that? And it might be a little tougher for you because, obviously I have these memorized, but you can go ahead, keep this right near you and go, okay, so miles to feet, feet to inches, right? And then inches to centimeters, always putting the garbage on the bottom so you can cancel. And now, how do I know I'm done? Because I have the unit I want, right? I have centimeters. Now I can go back and put the numbers in. Well, what numbers? That's tough to know. Well, feet I use this conversion factor, feet and miles. Looks like 5,280 goes to feet and 1 goes to mile. All right, 5,280, and then 1 right there. Okay, inches and feet. It looks like 1 foot and then 12 inches. All right, so the 1 has to go here because that's where feet is, and 12 has to go here because that's where inches is. So notice, but the units dictated whether they were top or bottom, right? Not the numbers. I don't care about the numbers, right? You might say, does the bigger number always go on top? No, not at all, right? I think, no, it just so happens in this time around it's true, but no, that's not always the case. Right up here, 2.2 went on bottom, and that's larger than 1. So yeah, so the larger number doesn't always go on top. That's ridiculous. All right, so now 2.54 goes to centimeters, so that's going to go right here. And the 1 will go on bottom with inches. All right, so now we can go ahead and go to the next step, which is multiply the top across, multiply the bottom across, and divide, right? Because remember, this is just one giant fraction. All right, there's a 1 there. All right, so multiply top across. I'm not going to write any 1s. That's a 1. 1 times 5,280 times 1 times 12. Get to write that. Times 1 times 2.54 times centimeters. Don't forget your units, right? Units are just as important as the numbers. And that's something that hasn't maybe been true in math class, or in this class. It's super important. So the units, that's the whole reason we did this problem. So you can't ignore those. All right, 1 times 1 times 1 times 1 times 1 times 1 times 1. Not always going to be the case, right? We just got lucky on that one. All right, so now we get our calculator, multiply these 3 across, divide by 1, which is just going to be whatever this number is. Looks like it's going to be a large number, but this is centimeters. There's 100 centimeters in a meter. There's like 30.48 centimeters in a foot. So we expect there to be a lot of these in 1 mile, and there will be. Let's multiply those 3 numbers. 5,280 times 12 times 2.54 is equal to 160,934.4 centimeters. And there's your answer. All right, pretty good. All right, let's go to the next one. How many feet are in a meter? Now you might say that's easy. 3 feet are in a meter, and no, that's wrong. You can add that conversion factor right up here. That would be 1 yard. 1 yard is equal to 3 feet. Now, a meter is very close to a yard, but a yardstick is actually smaller than a meter stick. So a meter stick is larger than 3 feet, and let's prove it, right? So how many feet are in a meter? Okay, so we have 1 meter equals blank feet. All right, so for this one, sorry, there's a little bit of shadow there. For this one, start by writing what we have. Well, do we start with meters or feet? We start with meters because we know there's 1 of them. So 1 meter. And then I got to find a bridge here to go from meters to feet. All right, go back to my sheet here. And, well, I see meters over here, meters to kilometers, meters to centimeters. Meters to millimeters, kilometers or kilometers. Oh boy, to miles. I'm thinking there's a lot of ways to do this one again. I'm thinking meters to centimeters, centimeters to inches, inches to feet. I think that way it makes the most sense. So once again, meters to centimeters, centimeters to inches, inches to feet. All right, so if you can't see that as quickly, right, a three-step problem, this takes some practice, that's all, right? And if you can't really do these wrong, but you just got to kind of see a bridge and just, you might say, well, what if I took some different path and I used 5 conversion factors? That's fine, as long as each time you write the conversion factor correctly and you're multiplying by 1, it's okay. You can multiply by 1 as many times as you want. It's not going to change the number, right? All right, so let's come back to here. So our first one was 1 meter equals 100 centimeters. All right, so we're saying we're in meters and we're going to get to centimeters. So the meters have to go away. So I'm going to write it across like that. Put the trash on bottom. All right. And centimeters goes on top. Now I'm in centimeters. And notice I don't care about the numbers right now. I'll do that later. I'm in centimeters and I want to get closer to feet, right? That's the idea. I want to get closer to feet. So I'm thinking then I can get from centimeters into inches, right? Because inches is close to feet. All right, so centimeters to inches. So I want to get rid of centimeters. So I'll put centimeters on bottom. Cancel, it's the best part. And inches goes on top. All right, now I'm in inches. That didn't quite answer my question. I want to be in feet. So now I get to do the obvious one, which is 12 inches equals a foot. But what goes on top here? 12 inches or 1 foot? And we'll just do what you did before, right? So you have inches here. You want to put inches on bottom so you can get rid of it. And feet gets to go on top. And now the numbers go in with the units, right? We know 1 foot is 12 inches. We go back and look at our page. We know 1 inch is equal to 2.54 centimeters, right? They tell us that. See right here, just 2.54 goes with the centimeters, so I put it right there. And the 1 goes with the inch, so I put that right there. And then finally, the meters and centimeters, well, it looks like the 1 goes with the meters and the 100 goes with the centimeters. So 1 right here, 100 right here. All right. See, yeah, that's it, right? And I'm done because I'm now in feet. But, you know, we're only halfway there, or we're most of the way there. We got to finally multiply the top, multiply the bottom, and divide, right? It's one giant fraction party, and that's why we can cancel, you know, because it's all just one fraction. All right, so I'm going to go ahead and rewrite. This is where you can see the rewrite step helps to clean this up. 1 times 1 times 100 times 1 times 1 times 1 times 1 times feet. All right, on the bottom, 1 times 1 times 1 times 2.54 times 1 times 12 times 1. All right, so that's what we have there, right? Okay, let's go ahead and I'm gonna simplify this. I'm gonna multiply these two first because I don't know 100 divided. I don't always trust myself on my calculator using parentheses, so. And I know some of you guys with your calculators, when you take shortcuts, make mistakes. So I'm going to be careful and do the 2.54 times 12, 30.48. All right. All right, and that's, so we have 100 feet divided by 30.48. How many times does 30 go into 100? About 3. But a little more, right? With some left over, about 8 left over. So about 3 1/3 maybe? 3.3 times. This goes in there 3.3 times. All right, let's find out, right? Let's go ahead and divide this in our calculator. 100 divided by 30.48. Always type in the top number first, then divided by the bottom number, the denominator. 30.48 is equal to 3.28. Now you might say, well, cool, I didn't know that. 3.28 feet is equal to 1 meter. So I'm going to write that right at the bottom. 1 meter equals. Now you might say, well, that's a conversion factor. And I'd be like, yes, you're right. It's not exact. None of them, there's a few on there that aren't completely exact, but it's close. And you might say, well, why don't you just tell us that one on the sheet? Well, I didn't tell you that one. I don't have that one memorized. I don't give you that one. I give you this one, so you got to use the tools you have. And a student might say, well, what if I memorize that one and then use it on the test? I would say, okay, yeah, I mean, you're fine with memorizing this one if you want to use it, but just make sure that you know it. Make sure that you get it right. This is also why on the first test, which goes over conversion factors, I don't allow these calculators, the scientific ones. I make you use I'll let you use scientific ones, but I only use the graphing ones, because a lot of times the graphing ones have conversion factors on here. Like, for instance, this is an old 85. This is actually from when I was in high school, and I still have this one, and it still works awesome. I hit second, and then CONV, which is conversion, and you can see here I have all these things here. So if I was to type in length, and then I'm given these choices, and I hit 1, and then I see M here for meters, so I'm going to plus F3, and I'm going to convert it to, it says 1 meter converted to, I'm going to hit the feet button, which is right there, feet, and then hit equal 3.28. Haha. Yeah, so your calculator can do all of this, and your calculators are really smooth. And this one's technology from when I was in high school, and I remember our teachers would, if we use these on the test, sometimes they would come around and check our memory to make sure we didn't have stuff programmed in them, or they would take our batteries out to wipe the memories, and because they were afraid of us doing too much with them. I guess these were the cell phones of back then, back before you guys were born. So it's kind of crazy to think about it, but these are powerful, these devices. So anyways, so the first test, you can't use a graphing one. After that, you can, but the first test, I like you to use just a scientific one, non-graphing, because I want to see you can do the conversions this way. So this is a real powerful technique here, dimensional analysis, yeah, and it's pretty awesome. In chemistry class, it's sometimes referred to as stoichiometry if you use the same technique with conversion factors from a mole-to-mole ratio. So from a chemical reaction, you can build mole-to-mole conversion factors, right? And write that as these equalities. So anyways, it works in chemistry too. All right, let's do one more problem, and then we'll call it good there. Okay, on this last problem, let's say, trying to think of the best way to put this. Let's say you're traveling 100 miles per hour. And you might say, well, in physics class, we don't use miles, we use meters. And in physics class, we don't use hours, we use seconds. And so the question is 100 miles per hour is equal to how many meters per second? All right, so you can see, and this is kind of tricky, right? But there's some things implied here with this question. When we say 100 miles per hour, this means that if you went this speed, right, and this is pretty fast, so you shouldn't be going this speed. But if theoretically, if you were able to, maybe you're in another country where they didn't have speed limits and there was nobody around, so it was super safe, and the road was perfectly straight, and you were able to travel this speed, and in that case, this would mean in 1 hour, if you went this speed in 1 hour, you would go 100 miles, right? So that's what that's saying. So next time you're driving 25 miles per hour, if you keep driving that speed, in 1 hour you would go 25 miles. All right, that's how these rates work, right? Something that's divided by time, we call it a rate. It's a speed, and that's how they work. We'll talk more on that in the next chapter. So here, we want to know how many meters per 1 second is 100 miles per hour. So really we have to do two conversion factors here, even though we already have well, we'll get a 1 there at the end, right? So maybe I shouldn't even write that there because that's kind of confusing. So I'm gonna get rid of that. I'm gonna write it this way. Let me rewrite that. I'll rewrite it like this: is equal to blank meters per second. All right, so we want to convert the top from miles to meters and the bottom from hours to seconds. That's really all this is. It's the same way we did it last time, except now we have two problems for the price of one. We're going to convert the top and convert the bottom. And it doesn't matter where you start. So I think the bottom going from hours to second is a little easier, and then going from miles to meters. So, all right, let's go ahead and get started. So we start by writing what we have. Do we have miles per hour or meters per second? You'd say miles per hour, right? Because the number's over here. All right, so I'm going to go ahead and write 100 miles per hour per 1 hour. All right, and then I'm going to start by changing. Yeah. I said I'd change the bottom. I think it's a little easier. So let's start there, right? Okay. So here's the deal though. Check it out. If I want to change the bottom, then where would hours have to go in this equality? And you'd say, well, it's the flip now, right? Because before we were always working with things on top, so we throw the trash on bottom. But if we want to change the bottom to be seconds, we need to put the trash on top like that. And I don't know how many seconds are in an hour. Well, actually, it's 3,600. But let's say I didn't. And but I do know that there's 60 minutes in an hour. So I'm going to write minutes down here and put my 60 and my 1. So there's another conversion that could go on the sheet, right? And I would expect most students would know these two, that 60 minutes is equal to 1 hour, and that 1 hour, 1 minute is equal to 60 seconds, right? Okay, so I'm going to go from hours to minutes, minutes to seconds. Okay, so coming back here, I'm going to cancel off my hours. I wrote my numbers in a little early there, sorry. I'm in minutes now, and now I got to get to seconds, right? I want seconds on bottom. So once again, I'll put my trash on top, which is minutes, and put what I want, or what I'm going to, on bottom, which is seconds, and I can cancel these. Remember, it's one big fraction party, right? And so when you have something on top that's the same as the thing on bottom, you can cancel it. And that should make sense, right? 100 divided by 100 is 1. A minute divided by a minute is 1. It doesn't matter if that doesn't have a number, right? Anything divided by itself is 1. All right, so now I want to go from, let's see, oh, and I put numbers in. I didn't put my numbers in. So we said 1 minute is equal to 60 seconds. All right, so I could have just solved this by saying 3,600 seconds is equal to 1 hour, but I pretended I didn't know that, right? Because I know most of you don't know that. All right, now you might say, well, the next step is multiply the top across, multiply the bottom across, because we have what we want. But we really don't, right? We wanted meters per second. This is just seconds. So we should keep going, right? That's what the rules were. So we're not done yet. All right, so now we're going to work off the top, and we want to get from miles to meters. I'm thinking here we can go from miles to kilometers, kilometers to meters, two conversion factors, right? Miles to kilometers, kilometers to meters. All right, so what I'm going to do then is I'm going to work long distance, right? It's just one giant fraction, just extending the fraction party. So that means miles is now the trash unit, right? Because I want to go from miles to kilometers, right? So miles is going to go on the bottom. So why on the bottom this time? Because look, I want to cancel those, right? And so that's why I had to go down there. And kilometer goes on top. But I don't want kilometers, I want meters, so I need one more Once again, where does the trash go? Well, again, on bottom. And meters goes on top. And just so I can cancel this, and I'm left with meters. Now I go ahead and put my numbers all in. So it looks like going back to here with kilometers and miles, the 1 went with miles and the 1.609 goes with kilometers. And with the other one, it looks like the 1,000 went with meters and the 1 goes with kilometers. And be careful there with this conversion factor because, or this conversion, because I could have just as easily given you, I usually write the bigger unit as 1, but what if I had given you this for a conversion factor, right? 1 meter, and is equal to 0.001 kilometer, right? These are this still works. This is fine to use. So just be careful there when you write these, and either one is acceptable, but they look way different. And I just wanted to point that out because you might say, well, which one's the right one? Well, they're both right. This one says 1 meter is equal to a really small big unit, and this is saying that 1 big unit, kilometer, is equal to a lot of really small meters. Okay. So coming back to here, now we're done, right? We have meters on top, seconds on bottom, all the other units are gone. And so now the next step is rewrite and multiply the top across, multiply the bottom across, and divide. So I'm going to go ahead and rewrite. This is really nice here to rewrite. So 100, 1.609, 1,000. And meters. Don't forget your units. You work so hard to get those. They go just in the fraction. They can even get parentheses just like everything else. We treat them just like numbers. All right, 1. Let's do the bottom now. 1 hour is really 1. 60 minutes. 60 seconds. 1. Okay, so it's starting to look like this. Let's simplify just so it gets a little cleaner before we divide. So I'm saying multiply the top across, multiply the bottom across. So let's get out of this mode. Let's clear that. 100 times 1.609 times 1,000. Enter. So 160,900 for the top. Don't forget your units, meters. On the bottom, 60 times 60 is 6 times 6 is 36. Add the 2 zeros, 3,600 seconds. And now we can divide and just simplify, right? So divided by, my answer up there, divided by 3,600 is equal to 44.694. Or I can just say 44.69 and not worry about that other 4. As long as I keep 2 or 3 after the decimal, and this is going to be in meters per second. Okay, so all right, so there's a significant difference, right? We're saying that this is equal to 100 miles per 1 hour. That is the same as 44.69 meters per 1 second. And there's something else you can see here which is kind of cool, which, because we use meters per second a lot in this class. For instance, the speed of light is 3 times 10 to the 8th meters per second, right? That's about 670,000 miles per hour. But anyways, coming back to this, what's cool about this, as you can see, is that when you're given something in meters per second and you're like, I don't know how fast that is. Nobody knows, meters per second. It's stupid. It's in physics class and nobody gets physics. No, so when meters per second shows up, here's how you can think of it. And this is a good way to estimate. So if you're like, well, how many miles per hour is this roughly? What you can do is you can take this number, double it, right? Double it, you get 44. This is roughly 45. Double it, you get about 90, right? So 90, and then add a little bit to it, and you get 100. So that's kind of this little trick I have. So just so I know roughly, like if you were gonna give me, say, like 20 meters per second, and you're like, how many miles per hour is that? I would say roughly, if I was just guessing off the top of my head, I would say, well, take your 20, double it, that's 40, add some, maybe 45 miles per hour, right? That's just a good guess. And I just wanted to point that out. So that's a good way to go from meters per second to miles per hour. Because a lot of times in our class, we'll get these meters per second answers, and you're like, I just understand miles per hour because that's what I drive. And it helps, right? It helps you put things in context and understand them better. So that's the trick I use. All right, so that's it. And have a good day.